Just an announcement. I know some of you have already access to the video. The the lecture on Monday has been uploaded to my YouTube channel, so you can go there to access. I I try to have a different way to upload the video through some of the NCKU, our own system, but the first couple of weeks probably easier for me to just upload to YouTube so everybody can access. But later, maybe I should, subsequent lecture, I should probably put to a different place. Okay, so let me see. I'm already recording. I assume you can see my video already. Okay, good. All right, so I will start to talk about the curriculum, which is the content of the course. The first part of the course is related to, I call it operating system and the Unix environment. I explained a little bit last time on Monday. It is much more important for a C++ programmer to know about the operating system, the underlayer of the software that's related to the development and the execution of your program. Because the language is the only language, by the way, that's developed in the intention being able to access a lower layer hardware resources. So that's why I make a C a powerful language, but it's also a much harder language to learn comparing to, for example, Python. Right. So I'm going to start with this set of topic today. The following slides might be familiar to some of you, but if you're not familiar with that, that's okay, because I feel those are very important topic. I want to review anyway. If it's the first time you learned about this concept, perfect. Okay, and we will go over that. All right. I want to ask you a question. So we're over three topics. One is called bit. One is called byte. The other one is called address. Bit, byte, and address. That's what I like to cover at this moment. Can anyone share with us what's the meaning of a bit? What's bit? Anyone? You can answer in either English or Mandarin or French. All right. Seems to me everybody is still waking up. Have all of you drink at least 2 cups of coffee this morning? So I usually believe that if I don't go to Starbucks to contribute a few $100 to get your caffeine, I won't wake up. So next time, take that as my recommendation. No, I'm not. Okay. So a bit is just what we call, sometimes we call the binary information. So in a computer, the smallest amount of information is called a bit. So a bit is essentially binary, means that it can only have a 2 value, 0, 1. I mean, an integer is what we call decimal. Decimal means that you can have a digit. A decimal digit means that you have a 0 to 9, which is 10. You can have a 10 different possible value. A binary only have a 2, either 0 or 1. So have you heard about the term called hexadecimal? Hexadecimal. Right, right. Hexadecimal is 16, right? From 0 all the way to F. So that's another very popular representation about hexadecimal. Hexadecimal. Okay, let me ask you the question. How many bits are there if you want to represent a hexadecimal digits? This is a little bit advanced. So you know bit, right? Bit is a 0, 1. Then hexadecimal, the 0 to 15, right? 15 is F. So you said 4 bits, right? That's what you have. It's 4 bits. Okay, now that's great. So 4 bits you can represent hexadecimal So a bit is called a byte. All right, so this is definition. A bit is 0 to 1, and then a byte is 8 bits of information. All right. Byte in computer programming, especially in C programming, is a very important concept because usually we go by bytes. For example, if you want to represent an integer in C or C++, how many bytes? 4, right? 4 bytes. Okay. By the way, that is a practical correct answer, but it might not be correct, say 20 years ago. So we say today, a integer in C is 4 bytes. But just want to tell you that it used to be the computer is much smaller. An integer I can represent only with 2 bytes. At this moment, in the most commonly used hardware platform, the floating point or double precision floating point in a typical computer today is 8 bytes. But 20 or 30 years ago, it became 4 bytes. So, okay, so that's good for a Python programmer. You don't need to worry about that. An integer is integer, double precision, double is a double. But as a C programmer, especially you want to talk about memory allocation, you have to know there is a difference. So if you develop a program 20, 30 years ago, and at that time, the programmer might assume the integer are 2 bytes, then that program might not work today in the most advanced platform. Okay, so I always say, don't listen to me. Let's actually write the program to test it out, okay? I want to go out. I want to bring up my, okay, this is my, let me try to do a program let me call it int size dot C. Include stdio.h, include stdlib.h, int main void return 0. Okay, I always do this way to make sure. Okay, then I'm going to print printf the size of int is %d, and then I will say size of int. Let me see if this compile, because sometimes the format string might be doing something differently. So I'm going to do GCC int size.c. Okay, I know it's funny. It says LU. Okay. It used to be %d is okay, but now I have to do everything in %LU. So the compiler gave me the direction, so I will just do that. Okay, now I have no problem. And if I do /a.out, you see that let me show you the program again. It says the int size is 4. If you take a look at the program, what I did here is that I use this function called size of int. Okay, so make it more complicated. I can do this. I can say size of double, size of float, size of short, size of long, and size of long. So I provide different architecture, different data type. This is all basic data type in C, but they might have something else. maybe I will, this is, I want to format it nicely. And I want to have another one. Maybe this is your favor. At least this is my favor. The size of a voice star. So here I'm going to change int is still int, double, and float, and short. Oh, I forgot one more, but I will add it later. Long. This one's a long. And this one is a voice star. And the first line, I'm going to put it here. I'm going to upload this program to the GitHub, okay? So at some point, I probably should, I tried to do that right after class. And the first one is, I will use unsigned character. Just make it more interesting. And then I will say unsigned char. In fact, for this, doesn't matter. The result should be the same. Okay, I'm going to compile this program. I just put it together and then let's run the program. Okay, let's take a look. If you remember what I put down, this is a size off. I have two purposes. One is just basically tell you there's a difference between the bytes of memory we need to support each of the data type. And the second one, I want to tell you how to do that is using size off. Don't just listen to your instructor because that number changes. If I taught the course 20 years ago, the answer, if I run this program on a different platform, it's going to be different. So let's say the size of unsigned character is 1. So essentially either char, which is a character, or unsigned character. Later, I will probably refresh for those of you who didn't know, there is a difference between signed and unsigned representation of the data. And the size of an integer is a 4, no surprise. And the size of double is 8 byte, no surprise. And then there is a floating point, which is the single decision floating point is a 4 byte. And this is interesting. This used to be the integer. It used to be when I first wrote C program at that time, the integer is 2 bytes, 16 bits. So that's why it was still, now they changed it to be short. So short is 2 byte. And then long is basically a pretty long integer. So it's a long is 8 byte, long is 8 byte. By the way, there are so many different type of integer in C. You have a long, you have a long, you have a long in, you have unsigned long, unsigned long, unsigned long in. So there, if you think about that, there's huge amount of different data type. Usually I don't use most of them. I usually use long or unsigned long and int and unsigned in terms of the representation. Of course, I usually use double, but if you do machine learning, that's interesting. Machine learning, if you represent your model, so your large language model, if you're using double, 8 bits, sorry, double is 8 byte, 64-bit integer. If you represent your neural network as a floating point, if you use 64-bit, it's very precise, but it's going to be really huge and really slow. So most of the LLM today, large language model, internally, they're representing a probability as a floating point. They usually use float, which is a 32-bit. But I remember when I did my, I actually run my own Llama 2. So I said, wow, this is 32-bit is too much. I cannot run LLM on my little computer. So I actually convert the LLM into 16-bit. So I can represent a floating point with 16-bit. And now my LLM runs, my Llama 2 runs a lot faster. I can probably sometime, if you're interested, I can actually show you the performance difference between using 64-bit floating point versus 32-bit. If you talk about Professor Cai Jiaqi, he has been doing this very exciting work called model compression, and he's doing 4-bit instead of 32-bit. So 4-bit means that you squeeze all the number even much smaller, such that you can perform a machine learning or artificial intelligence program with much better performance. But then you lost some of the accuracy, of course, because you're squeezing the information from 32-bit or even from 64-bit over here. Okay, so that's something that's important for C programmer to know the size of the data, because the size of each of the data type is controllable by you. You choose how you want to represent information. And then you found out that at the hardware platform you're running, what's their exact size. Okay, the last one that's interesting. Can someone tell me what's voice star? What's voice star? There's no definition, right? Void. But what's the star? What star means? What? What's 指针 in? Pointer. Okay. See, thank you very much. What's the pointer's Chinese name? 指针. Okay. 指针. By the way, this is the first time I ever know the Chinese name for pointer. Okay, that's great. Thank you. Okay, good. So I use pointer. So now I know. Yeah, this is we call a generic pointer. So you can have an in star, you can have a long star, you can have a double star. But voice star means I have a generic pointer. Means that I don't want to clarify exactly the data type I'm going to pointing to. But now I have a generic pointer. Later, I can use some techniques called casting to cast this to be whatever type I want. This, by the way, is so important for C++. I believe casting, if you look at my curriculum, I actually have two places I will do casting. So if you remember in the C++, and here I talk about operator overloading, I talk about casting, introduction number 1. And then when I talk about multiple inheritance, I do casting revisit. So if I want to cast, means that I'm actually switching data type, from one data type to the other one. So this usually you will think about, why do I want to cast say an integer from double and things like that? So that sometimes happen. But in object-oriented programming language, casting becomes so critical. I almost have to cast a lot of time, almost like every single program, because when I handle the information, at the time I create the information or at the time I use the information, I might not immediately I know what's the data type. So I want to just very convenient. I said, it's a voice star. I know I'm pointing to something, but exactly what is the data type, whether this is integer or whether this is a particular object or this is the other very complicated object, I don't know, and I don't care. I will only do that until the data is coming in, because the object, so you can think about where's the object. You're not creating your object. You're going to download the object from Facebook. You're going to download the object from Google. And those objects coming in, and you don't know what their representation until you actually see the data. Until at that time, you will be able to know exactly what kind of pointer you're dealing with. So that's why, now I go back. I mean, don't worry about that. This is probably the most advanced concept in C++, is about casting. And casting, we will spend a lot of time into that. So here, I only want to know the representation of a pointer is 8 bytes. So let me ask you the other question. So voice star is a pointer. Thank you, 指针. Now I know. If this 指针 is 8 bytes, 8 bytes is how many bits? 64 bits, right? 64 bit. Okay, so I want you to guess, okay? You really have to write the program to test out. If I change this void to be an int, become an int star, what should be the answer over here? Still 8 byte, okay? So there is a difference between, this is the integer 4 byte, is the data. But int star represent the pointer, represent the address of that memory that you're storing that integer. Okay, so now let's see. This is a concept about pointer. By the way, I want to say if you learned C in the previous semester, the whatever Introduction to Computer Science 1, I believe, in my opinion, I have been teaching this course so for so many times. The hardest concept in the whole thing about C, C++ business is pointer. So I don't believe most of you really learn well the first time. I myself also I learned years before I really start to get a feeling about what pointer really is. Okay, so I'm going to try the second time. Don't worry about that. If you have something which is you are not sure from Introduction to Computer Science 1, perfect. You're in the right place. Where's my PowerPoint? Now I have to go back to my PowerPoint. Okay, here's what I want to show you. Okay, so I talk about a bit is 0, 1. A byte is 8-bit. In the programmer's mind, C program particularly, we're dealing with this what we call memory box. So here is a memory box, which is each of the box is 1 byte of information. Each of the box is 1 byte. And the thing is that more we have something we call addressable memory box. Addressable memory box means that each of the memory box, I need to know how to access to each of the memory. It's like where you live, or where's your mailbox, or where's your email address. So it has an address. So in the C programmers or C++, the same, that each of the box has an address, and the address I'm using a unsigned integer to represent. So the smallest address is a 0, and then 1, 2, 3, whatever, the number continue. So now you think about, you have this concept of one thing, you have a lots of box, that this box, each of the box, the unit is 1 byte. And then you have a way to address this bus, address each of the box individually. And that sometimes we call address, and sometimes we call it just a pointer. Okay, this is a pointer. So internal pointer, I mean, if you hear the word English or Mandarin, it looks like you have something pointing to that, right? You have something pointing to that. But internally, it just represents as an address. So you think about address is a pointer. For example, Google, you enter an address, Google actually pointing you to a particular GPS location, and then you can drive your car over there and walk over there, things like that. Okay, so this is address. That's pointer. Okay, any question about what I just said? This is a hard concept, by the way. If you feel very odd, you don't know why it is, it's okay. Anybody have any question? Okay, I know the best way to answer the question I just asked you. Write the program. I mean, let's write the program to see what happened. So I'm using the same program. Where's my program? It's over here. So I'm using this in size. Now I have a, let me do this. I define integer called x. And I set integer x value to be 1. By the way, if you, I assume most of you somewhat familiar with the syntax about the program I just put down there, except the size of, except some of the what we call format string. But if you have any question, understand every single character that I put down in this program, please feel free to ask me, and then I'll be happy to answer to you. So I define an integer called x, and then assign the initial value to be 1. All right. So now I can actually do this. I can print. I said the value of x is %LD \n, and then I just put x. And then I can say what's the address, which is a pointer. I would say the address of X, usually I do %P as a pointer. Let me tell you that the P, and then I put the MX, that's represent the address. All right, let's try to just do this and see what happens. Oh, they want me to put D this time. Okay, because is int, it's not okay, fine. I will put LD is basically a long, but okay, let me tell you what happened. Remember earlier, I have to change that to D to LU because size of int is actually returning a long. It's not returning integer, but now I'm actually X is an integer. So that's why integer is a %D. So how do I do that? Let me actually see. I can show you this. The other things I use a lot is using main. Doesn't have a size of. Great. Okay. Forget it. So now I'm doing this. Compile. A.L. Okay, now you can see that this two line. Let's just take a look at this two line. I just add this to this. So the value of X is what? Is an integer, and the value of X is 1. And then I said the address of X is this long number. This long number. Okay, so let me ask you the question, what kind of data representation this looks like? This is hexadecimal, 16进位. Right? This is hexadecimal. How do you know it's a hexadecimal? Because everything should be only 0 to 9 and then to A to F. Okay, 0 to 9 and then A to F represent all 16 from 0 to 15. So this is hexadecimal. Okay, can someone tell me how many bits of this hexadecimal number? How many bits of this hexadecimal number? Remember, I asked you, what is each hexadecimal digit? How many bits of that? How many bits you need to represent a hexadecimal digit? 4-bit, right? From 0 to 15. Remember, you guys provide your own answer. 4-bit. So how many hexadecimal digits I have here? 8 of them, right? 0x is just the prefix. You don't have to worry about that. So if you see hexadecimal number, is always started with 0x. By the way, I want to show you the difference in C a little bit here. I can print either with a %P or I can print as %X. Let me see the difference. If I remember, if the compiler let me go this time. I'm using, this is called, by the way, format string. Format string means I represent how I'm going to output the information from whatever data. What? It doesn't have, okay, it says I have to unsign integer argument. Okay, fine. You see that is basically complaining this format string say, hey, I want to put a unsigned int into an integer star because %X, they can only represent int star. So how do I deal with that? I'm a C programmer. I know how to hack. I'm using casting. So this is a great opportunity for you to introduce the concept called casting. I actually convert it to integer star. Okay, so if I do this, I do a casting. See, semantically, these two lines are the same. It's still %X, but I casting with an integer star. Casting to a different type of pointer so I can use %X to output. So let's try to print it. Let's try to compile this time. Still not allow me. The argument and sign. Oh, okay. I know. I'm sorry. I make a mistake. I make exactly the opposite. See, your instructor make a mistake all the time. So it's expecting unsigned int. Now it should be happy. Wait a minute. Unsigned int, but the argument has, okay. Now I think I know what happened, but that doesn't make sense. Do I have LX? I might need a LX, sorry. And here I have to say unsigned loan. Now it's work. Okay, I will explain to you what happened. So now I can print the output. You can see now, what's the difference? The difference is just a format between %P and %X. By the way, it has to be %LX. I'll tell you the difference between %X and %LX. It's just one is 4 byte, one is 8 byte. So you can see that I'm actually printing the same information. They are both hexadecimal, but if I print it as a pointer, the output will have a 0x as its prefix. But the rest of the digits are exactly the same, 8 byte. Okay, so just a address. I mean, sometimes this is very tedious. Sometimes I say I hate this language because it's so specific. I have to do everything match exactly in order to get the output I want. All right, so that's the difference. But the important thing is that this address has 8. Sorry, 1, 2, 3, 4, 5, 6. Wait a minute. How many bits? It actually have more than 8. How can that happen? It has a 9. That's interesting. Why is that?
Yeah, those would be bytes.
Right, 2 is 1 byte. So this is a 9 bytes. I'm expecting this has a 16 byte, by the way. Let me try a little bit different. This is even a bit surprise to me, to be honest. But I'm going to do this. I'm going to do this first because the size is 8 byte, so it's supposed to be 16. So I'm going to do this %. Let me do %16P and 16 LX. Let's see what happened. Let me see compiler allow this or not. Okay. So no, I cannot actually tell. Can I easily tell? Because I kind of try to print all 16 bytes. So that's why it has a few. I mean, my guess is the first few bytes, they're all 0. The address, because it has a 9 digits, but totally should have 16 hexadecimal digits. So representing 64 bits. The reason I want to do this is that I want to actually get back to this. Is what's the size about the memory, which is 8 byte, which is 64 bits, which now I go back to my PowerPoint. Where's my PowerPoint? Here. So I want to go back to this slide and then I'm going to take a break. So the concept is I have a byte. Each of the box is a byte. And then I have a concept called address, which is now you have to believe me, unless we found a way to print exactly that 16 byte, which we will do that after the break. I have a way to do that, by the way. And then I'm going to have this, each of this has an address, and that address, I call it a pointer. And later I will show you why that's a pointer when we after the break. And then the important thing I want to get at this point is that the size, the representation of the address in C, at least in this computer, is 64 bits. Because it's 8 byte, so 64 bits. Have you heard about the concept called 64-bit computer versus 32-bit computer? You have to see that. And when people talk about 64-bit computer, That's actually represent what's the size of your address. What's the size of your address? So if you have a 64-bit computer, that means you can address both more memory box. If you have a 64-bit computer, do you know what I mean? Because you can have a 2 to the 64 different address. But if you have a 32 computer, you can only address to memory of size 2 to the 32. So this is the difference between, sorry, I have to escape. I will go put it down here. Where's my text box? Text box. Okay. This is 2 to the 64 versus 2 to the 32. And that's a huge difference. As we progress, I mean, the first computer I probably ever done is 8-bits computer. At that time, in the 80s, the most popular microprocessor were 8-bits. So that means addressability is 8-bits. That's really, really small compared to the modern computer today, which is 2 to the 64. And this is exponential bigger. Okay, this is huge. If you have a 2 to the 32, the largest things you can have is 2 to the 32, which means 4 gigabyte. And today, if you want to watch a movie, that's usually more than 4 gigabyte. If you look at the newest format. So today, that's why we progress to 2 to the 64. Okay, so let's actually just use this slide for before the break. I want you to learn a few things. Number one, what's the concept of bit? What's the concept of byte? What's the concept of addressable memory box? And what's the concept of the address itself? The address is for the computer use size of, you actually know is 64-bit computer. Okay. All right. Any question? We're going to take, what I want to do is I don't want to continue to move on to the next subject unless we all more or less understand the concept on this slide. Okay, any question? By the way, what I hope to do next is have each of your computer to install something called WSL, which is let me get back to here. In the syllabus, the subject is called WSL, Windows Subsystem for Linux, so you can run it on the ASUS machine in front of you. But it might be better if you have your own computer. If your computer is a Mac, you don't need to do anything because the Mac is already a Unix operating system. You can do everything pretty much in this class, use a Mac directly. But if you are having a Windows laptop, you need to install something called WSL, Windows Subsystem for Linux. Then you can have a very good Linux environment, which is compatible to this, that you can bring it to class and you can run every single program I presented here. You can even just pull it out. Okay, so let me ask you, how many of you who intend to use your own laptop for this course? Okay, somebody. Let me ask the question: how many of you you don't want to use your own laptop, or you don't have access to a laptop that you can? I mean, by the way, I'm not asking you to reformat your hard drive on your Windows machine. It's just an application layer. I can do a WSL. How many of you probably want to use a computer here when I'm teaching? Okay. So you know what? I will at least create next time maybe 2-row computer install WSL. And then the rest of the student, I will talk to the staff to help me to do that. And the rest of you can bring your computer, but I will try to install as many as we can by next time we meet. Okay. Any question regarding this slide before I move on? Any question regarding this slide? Okay, so don't be shy. Okay, just you can always ask question anytime. Just raise your hand. So I'm going to follow up this a little bit. I want to do two things. That what bothers me as a programmer. By the way, this is something which is this is a mentality about a C programmer. We realize the program always bothers us, so we want to try different things to actually confirm what our understanding about our program and the hardware we're dealing with. So this is, by the way, a little bit different between C programmer and Python programmer. The Python programmer is, okay, the program works, that's good. But C programmer, we always say, hey, what's my program interact with the hardware I'm dealing with? Because C programmer, you will realize that the hardware, you're going to run the same program on different hardware platform, the result might be dramatically different. I have personally so many experience I can share with you later if we have time. But let's actually try to dig out a little bit. Number one, exactly what's that 64-bit address? And the other one, what's the difference between address and pointer in C syntax? Okay, let's try to do that. I want to do 1 minute and then we can take a break here. Let me do this. Let me try to run this program. Okay, so now I'm going to do an array. I would say this is unsigned character array of X as address, which is I'm going to put 8 byte. I'm going to put 8 byte. And I'm going to do integer star, which is XP. Okay, and then I'm going to do this. Then I'm going to do XP is equal to MX. Okay, I'm going to just stop here to tell you the syntax. Just orally, without running the program. I define a 8-byte array, which is I intend to use this array to store my address. So that's why I said 64-bit, 8-byte. I create that. And I create another definition, which you might notice if I have an integer star. In fact, I should do this. Make it more. I mean, by the way, syntactically, C will understand all combination. The space doesn't matter. So I can do integer star XP, which means that XP is declared as a pointer to an integer. And then I assign the NP, which is the address of X, into this pointer X, XP. Okay, I'm going to continue. So let's take a 10 minutes break, and then we come back. Okay.